Good morning, good afternoon, year nines. Today's lesson is resultant force. The learning outcome is calculate resultant force and explain the effect. Now, today's lesson, you're going to need a pen, pencil, ruler, your books, your A3, A4 pad of notepad, and access to a computer or tablet to access the Google Forms. Now, what you now need to do now is start answering the do now questions on the Google Forms. Also, please make sure you put your first name, your surname, and tick off which class group you are as well. So you might want to pause the video at this point here and answer the do now questions. Now, the answers will present itself here, so you're able to see what you got right and what you got wrong. The learning outcomes today is to define balanced and unbalanced forces, describe the effect on motion of balanced and unbalanced forces, and calculate the resultant force acting on an object. So, as we know, forces can be balanced or unbalanced. And now, when forces are balanced, the object's motions will not change, meaning the object will be stationary. But when the forces are unbalanced, the object's motion will change, making it speed up, accelerate, slow down, or decelerate. So a couple of examples here for you, which you probably want to get down, is that balanced forces are stationary or constant speed, and unbalanced is acceleration or accelerate, decelerate, change of direction, stretch, or compress. Now, so far we have learned that there are different forces interacting all around us. At different times. Now, today we're going to use this knowledge to compare the size of opposite forces and see if they're balanced, the same, or not balanced, and that they are different. So for this example here, the resultant force is to the right, so the plane would accelerate in a rightward direction. As you can see, the arrow to the right is much greater. In this example, the resultant force is to the left, so the plane would accelerate in the leftwards direction. Now, if the forces acting on an object are unbalanced, the object must be accelerating or decelerating. Now, if an object is accelerating, it is speeding up. If an object is decelerating, it is slowing down. If an object is accelerating, the force in the direction of travel will be greater than the opposing force. So, for example, this skydiver has just jumped out of a plane and is accelerating towards the ground as a downward force is greater than the opposing force. So here we have a free body diagram showing balanced forces in opposite directions. Now the arrows represent the force vector. So the length of the arrow represents the magnitude of the force. So as you can see here the forces are unbalanced and the object will accelerate in a downwards direction. Now, for this example here, the forces are unbalanced, so the object will accelerate in the rightwards direction. Now, in this scenario here, what you need to tell me is the object balanced or unbalanced, and what direction will it accelerate? So you may want to pause at the moment and just answer that question. So the second diagram shows a resultant force. Now, sometimes this is the second diagram you may see in a higher paper or in for an exam question. Now, a single force. So the second diagram shows a resultant force, a single force that has the same effect as all the original forces acting together. So as an example, if you look at the left diagram, as you can see, it's 90 newtons going to the left and 100 newtons going to the right. Now, as we know, if we take the difference from them, that it will be 10 newtons going to the right. So that's what it means in regards to the second diagram. So this question here, so what would be the resultant force acting on the object? So what you need to do here is just work out. So you do 190 take away 90, and the resultant force will be 100 newtons going to the right. So that is the difference. Now this is for higher tiers only. Now we also need to be able to calculate the resultant force of two forces acting at an angle. Now, for example, this boat has broken down and is being pulled by two boats at different angles. So firstly, what you need to do, so to calculate the resultant force, turning the two forces into one, we do this by drawing a parallelogram of forces. Now, the first step is to measure the vector representing the force using a ruler. The second step is then to draw that force the exact same length parallel to the other force measured, so touching the second force, just like that. Now, the next step is then to measure the length of the vector representing the second force, and then draw the second vector the exact same length parallel to the vector measured, so completing the parallelogram. What you'll do then, to work out the length of the resultant force, we then draw the resultant vector from the origin, so the point where the two vectors meet, so the point where the two vectors have been drawn together. You will then measure the length of this vector. Now, to work out the size of the force, you need a scale. Now, what we need to think about here is that when we first measured the first diagram, so the first line, it was 5 centimeters and it had 300 newtons. So what you do is you have to try and find out how much was 1 centimeter. So what you'll do 300 divided by 5 to give you 60 newtons. Now, to work out the resultant vector, you will then do 60 newtons times the length of the line meeting that was drawn from point to point. So you'll do 60 times 10 centimeters, which will give you a force of 600 newtons. Now, this part here, remember, look, cover, write, check. So make sure you look at the first question, you cover the first answer, rewrite the answer in your back of your books, and then check if you got that right. If you've got that right, please move on to the following questions. If you haven't, go back and make sure you look over the first question and answer it again. Now, you may want to spend the next 2 minutes quizzing your siblings or your parents to help you out. So what we have here now is the recall quiz. Now, you want to make sure that you pause the video here and answer the recall quiz on the Google form for me, please. So I'll go through the answers very quickly. So which statement is true? So objects with unbalanced forces accelerate, decelerate, or can be stretched or compressed. To calculate resultant force, what do we need to do? So you add forces acting in the same directions. A resultant force is a single force that has the same effect as all the original forces acting together. Which statement is true? The forces on this object are unbalanced. Which statement is true? This object would accelerate right. Now, application task. So remember, this is the I do. So what you need to do here is trying to work out which way the resultant force will be going, and if it will be stationary or moving right or left, for example. So as we can see here, the size is 5 newtons. You do 5 newtons, take away 4 newtons, which will give me 1 newton. So as you know, it'll be 1 newton to the left of the direction. Now, what you need to do after this, you need to do the we do and the you do task on the Google form before you continue. So make sure you pause the video here before we go through the answers. Now, the answers here, as you can see, it will be 5 newtons to the left. You'll then have to work this out. So to calculate, you need to make sure you're calculating resultant force acting on each of these objects. And the answers are presented here for you. So you may want to pause it at this moment. Now, moving on, the progress check. So give the resultant force is these are follow-up questions to test your ability. And the answers are here for you. Now, you'll have an independent task where you need to make sure you are completing. So it's a balanced and unbalanced forces worksheet. So very similar to what you've been doing now. The answers will be presented afterwards. Now, This is for the higher tier students for set one and set two. And now on the application task sheet, the first section is is a faded example on the sheet for pupils to refer to. Now this is a simple first step of practicing drawing resultant forces without calculating the size of a resultant force that we do. So the first step to work out the resultant force of these two forces at an angle is you measure one force and you draw it parallel to the vector touching the other vector. Very similar to what we did before. Second step to measure and copy the second vector to connect the parallelogram. You'll draw and draw the resultant vector touching the two origins. So now what you will do, you should now be trying to do the we do task. So you may want to pause the video at this moment, and then I'll go through this very quickly. Now, what you should be doing the high test students, so in set one and set two, you should be completing the questions 1, 2, and 3. These are the answers here for you. Make sure you complete the questions 5, 6, and 7. Now, we've now moved on to the plenary. So what you need to do is make sure you've answered all of the application tasks, the do now task, the recall quiz, and the plenary on the Google form, and that will be the end of today's lesson. Thank you.